Hello, everybody. Thank you very much for joining us today. I am very excited to be holding this webinar since, as Odelia said, it is dedicated to our newly released CHEPS accessory CHEPS thermode for TSA2 device. And I hope that reviewing its exciting capabilities and features and the benefits it may bring into your research or clinical work will be interesting and informative for you. So let's begin. In our agenda for today is first of all a very short and brief review of the TSA device. We had a webinar dedicated to the TSA2 device back in September. So today we will really not go into that much details about the device itself. We will review it briefly with putting a flashlight on the features and the capabilities that are relevant for CHEPS. And if any of you would like to hear more about the TSA2 device, please let us know and we can send the recorded webinar from September to you. Then we will review the CHEPS for TSA and its technical specifications and capabilities. Then we will talk about the software side of the story. We will talk about the Pulses program. We will overview it, discuss what you can control, can or cannot control, look at the software a little bit. Then we will talk about the potential applications and potential uses of the CHEPS for TSA accessory. We will talk about contact heat and cold evoked potentials. We will talk about phasic temporal summation and about some other uses of the CHEPS for TSA. So let's start from looking at the device. So here you can see the picture of the back panel and front panel of it. But just for the sake of understanding the dimensions of the device, looking at it a little bit, I would like to show it to you. I will turn my computer now and show you the device. You can see that it is a tabletop device, not very big, portable, has its handle, it can be, took around, has thermode sitting on it, and I will show the thermode closer now to the camera. So really just to show you how the device looks like in the real life. And now back to me. All right. So our new TSA2 device was introduced to the market a little bit more than a year ago, and it is really our latest advance in thermal stimulation. We have this portable device with high precision and robustness, and its software and hardware capabilities can really allow you to do almost any type of thermal stimulation you can think about, starting from simple QST, simple thermal testing, doing some sensory and pain thresholds, and up to very sophisticated research protocols in which you can combine your thermal stimulation with other stimulation types, with tasks, use it in the scanner, use it combined with EEG, etc., etc. Really many capabilities in one device. If we review the possible accessories for TSA2 device, so we have the 30 by 30 thermode, which is the standard one that is usually used for quantitative sensory testing and for other thermal testing modalities. There is also 16 by 16 smaller size thermode for face, for smaller surface areas, for testing in children, for example. And both of these thermodes are available in fMRI configuration. And now, as I said, we very recently released the new CHEPS thermode, which connects to the same device and allows the capabilities that we will review: fast rates, wide temperature range. We will very soon be releasing the fMRI version of it. We are already working on it, and it will be very soon released. And then we will later release the additional accessories such as small surface thermode, 6 millimeter diameter, what was previously called intraoral thermode, the one that allows you to really test very small area and differentiate between the different points, and intravaginal thermode for genital sensory assessment. And this is the CHEPS thermode, and I will show it now to the camera so you all again look at that. So this is the thermode. Here are the straps that can allow to attach it and to strap it to any body area. We have also longer straps if needed to be attached to the leg or to the back or something like that. If we talk about the upgradability of TSA2, this is one of the main advantages this platform brings. It is easily upgradable to any configuration you will choose to use. So if, for example, in the past month you purchased the device with just a simple 30 by 30 thermode and you want at some point to take it into the scanner, you can just add the fMRI thermode to your existing device and just like that, plug and play, start working in MRI scanner. Same states for different thermode sizes and same states for CHEPS thermode. You just need to connect it and you can use it right away. How it is connected to the device. So if you noticed, we in previous slide, I mentioned that it can be used in dual. The TSA2 has dual thermode configuration, meaning two thermodes can be attached to the TSA at the same time and be used simultaneously. This is true for 30 by 30 and 16 by 16 thermode. This is not true for CHEPS thermode, and you can see on this picture why. Because to use CHEPS stimulation, fast rates, wide temperature range, you need more power. And that is why we use the two electrical connectors to connect the CHEPS thermode. So you can see that two water connectors are connected, and the green and the blue electrical connectors are connected to your TSA device. And that is the reason that we can't use it in dual thermode configuration, but it works perfectly in single thermode configuration. And the device can heat and cool the thermode CHEPS rapidly, as we will review in a minute. So if we move to the technical specifications of the CHEPS thermode for TSA2, maximum heating rate is 70 degrees per second. Maximum cooling rate is 40 degrees per second. And for those of you who are or were using our previous CHEPS generation thermode, pathway CHEPS, these are not new to you. These are the rates that you were working with the previous version of pathway CHEPS. But what is really new and exciting here that now you can work in these fast rates in much wider temperature range. If for previous generation of CHEPS, the temperature range was 30 to 55 degrees, and it actually allowed only the heat rapid stimulation. Now you can work from 0 to 55, and it allows using these rates of 70 degrees per second up and 40 degrees per second down in the whole temperature range from 0 to 55, allowing rapid cold stimulation, which is new and exciting. So again, if you look at the thermode, the active surface is 24 by 24 millimeters. Total active surface is 576 square millimeters. Again, for those of you who are aware of previous generation, that we kept the surface the same, actually 2 square millimeters larger, because we know that large and continuous heating and cooling of surface area is very important for the robustness of the stimulus. And that is why it was very important for us to keep large and continuous stimulation surface of the thermode. As I mentioned, fMRI CHEPS thermode will be available soon. It will have a built-in fMRI filter, a small one, and it will be able to just to connect to the same TSA2 device you may already have and go into the scanner and work there. And last but not least, we have CE and FDA approvals for this system, including the CHEPS accessory. And this is important for two reasons. First of all, it is important for your university IRB or ethics committee or to your hospital biomedical engineering department. It is usually a request. So if needed, our local distributors can supply these certificates to you. for your use. And the second reason, not less important, is that having this certificate in place can assure you that the device is perfectly safe to use. It stands in all medical standards, and all the safety tests were performed. All the safety mechanisms and limitations are in place, so you can safely use it on your subjects or patients. If we talk about the CHEPS for TSA benefits and how it can assist you in your research or clinical work, so with the new CHEPS for the thermode, you can perform contact heat evoked potentials, which we will review in a couple of slides, how and what is it good for. You can perform now the cold evoked potentials, which was not possible or only slightly possible in previous pathway CHEPS accessory. Now you can go to 12, to 10 degrees, to 7 degrees, do evoked potential, do a sharp stimulation and see a very nice cold evoked potential. Again, we will review it in a few slides from now to more details. You can use the fast rates for phasic temporal summation, which requires fast stimulation, and for additional thermal testing modalities for different types of tonic stimulation, in which you reach the destination very fast and stay there for as long as requested. And also it allows you to use the cold and hot stimulation in MRI scanner with higher thermal resolution, which is important. Now let's look at the software side and talk about the very useful program when you're working with CHEPS for TSA. This program is called Pulses, and it allows you to do pulses, heat or cold, rapid heat or cold stimulation. What is important to know about Pulses program? First of all, in Pulses program, there are always maximum possible rates applied. So you can't change it. In Pulses program, you have it works always with 70 degrees per second up and 40 degrees per second down. If you want to play with it, I will show you later how you can do that with the ramp and hold program. But if you're using a Pulses program, you will always have maximum possible rates in place. What you can control is the baseline that you start from, this line here. You can start from different baselines depending on which protocol you are trying to follow. You can control the destination temperature, where you want to go, up or down. You can control number of trials, meaning number of pulses in the stimulation, or you can control number of pulses in the trial. So you can go up, stay there, do 3 or 4 pulses from high to low destination, and then go back to the baseline. And I will show you how it looks like in a second. And you can control the ISI, intrastimulus interval, interval between the stimuli. You can make it shorter, longer. You can control it depending again on the protocol. And this is similar for hot and for cold stimulation. So let's switch to the software. Again, for those of you who already worked or work with Medoc products, you recognize the UI. This is our Medoc main station software. We try to keep it the same UI so our users can continue using it without needing to, learn that much of new information. And let's just have a look at one Pulses program that I prepared for this. So these are the parameters you can control. You control the baseline. It should be in the range of 30 to 45, but you can play within this range, you can play with it. You control the destination. Now you can see that here you have high destination and low destination. High destination is applicable when you're using heat modality, and low destination is important when you're using cold modality, but I will show it to you in a second. Then you can control the number of trials, meaning how many pulses there will be in the sequence of stimulation. And you can control number of pulses in trial, so how many times it will go from high to low destination when it's achieved the high destination. So you can see that in this case, I asked for high destination of 50, And for low destination, that is similar to the baseline because I don't want it to do pulses inside the trial. I ask for 5 trials, each one containing 1 pulse. So if you will look at this, you will see 5 pulses. And if I will ask, for example, for low destination of 45, and I will say I want 3 pulses in each trial, I will have something like that. So I'm not sure you can see it with this zoom, but just 1 second. Yeah, here you can see this. So you can do also this type of stimulation if you find it useful. And you can, of course, control the ISI, minimum and maximum, because sometimes you would like to set the minimum time between trials and the maximum time between trials. And then the software will randomly select the time between the min and the max, which can reduce the expectation effect and stuff. So I want to have it back to the simple stimulation just to show you how it looked like when you run the test. So after you're satisfied with your program, you can just run the test using the program we just edited. And you can see that after 5 seconds, we will see pulses starting to 50 degrees with 8 to 10 seconds between them. Here on the upper side part of the screen, you can see the counting of the waiting time, which trial of how many it is, etc. So we will go back to this, to software and to reviewing the pulses program when we will talk about contact heat evoked potentials and cold evoked potentials, right? So I will go back to my presentation, and I think it's a good time for questions. I will just stop sharing my screen. Look at the questions. I will try to answer as many as I can, but if somebody will not receive an answer, because I see that we have quite a lot. So if I will not have time to get to all of your questions, be sure that I will get back to you in an email with the answer. So what question shall we start with? Just one moment. Well, does the TSA2 CHEPS do the same as the pathway CHEPS? So it's a good question. I already reviewed part of the differences. It does the same, but more. It has the same heating rate of 70 degrees per second. It has the same large stimulation surface, but in addition to this, it can go also down to low temperatures and have cold evoked potentials or any other types of cold rapid stimulation. Um, what is the advantage of making the stimulus longer with ramp and hold? We will review this when we go to the temporal summation part, but sometimes if you want the stimulation to be more painful, you want to stay at the destination a little bit. And as I said, you can control it in pulses program, but you will be able to control it in ramp and hold, and I will show it to you later at this presentation. Well, there are not that many questions. All right. Uh, just one moment. I want to see I didn't miss any. I think that's it for now. I will go back to my presentation. All right. And now we will dedicate the second part of our webinar to reviewing the applications and the potential uses of the CHEPS for TSA2. After we review the technical part of it, we will go a little bit into more into the application part of it. So first potential use that I would like to review is the heat and cold evoked potentials. For those of you who are not coming from this field and maybe not that much aware about the technique, evoked potential can be recorded using EEG as a result of many types of stimuli. It can be visual evoked potentials, it can be audio evoked potential, electrical evoked, etc. When we talk about contact heat evoked potential, we talk about evoked potential recorded by the EEG device as a result of sharp, usually painful heat stimulation. So what do you need to record a good evoked potential? You need, first of all, this type of sharp, painful, fast stimulation. And you can do this with our CHEPS accessory. You can use 70 degrees per second up and 40 degrees per second down. You can go to very high temperatures up to 55 degrees. You can use different baselines. We know from the literature that some protocols ask for 32 degrees baseline, some ask for 35 degrees of a baseline, some even for 42. We know that there is a technique introduced by a group in Switzerland, led by Professor Armin Kurt, that they suggest that using the increased baseline will help to record evoked potentials from lower limb in elderly patients, cases in which recording can be a bit more challenging than in, just recording from the face or from the hand of a young subject or patient. Another thing that you need to record good evoked potential is the full synchronization with EEG device, and this can also be done with our device and our software. You have TTL in and out capabilities. You have TTL in and out connectors on the back panel of the device. You can connect with simple BNC cable to your EEG device. Why is synchronization important? Because we measure in evoked potential two main parameters. You can look here at a picture of evoked potential. We measure the amplitude, N to P2, meaning how strong was the evoked potential, how intense, and we measure the latency. What is the latency? Is the time that passes from the moment the stimulation was given until the moment the evoked potential is visible. It started in EEG recording. So we need to let EEG know when the stimulation started. And this can be done with sending TTL out to EEG device or with starting the stimulation by TTL in sent by EEG device to our TSA2 device. So really many options and any protocol you would like to follow, you will be able to do that. What is it good for? What can you use this in nice technique for? Contact heat evoked potentials. So first of all, since these are painful stimulation, painful heat stimulation, we understand that it is mediated by small fibers. So if something is wrong in small fibers, we will see smaller amplitude, we will see longer latency, and therefore it can be a good tool for the assessment of small fiber functionality of the patient. And this is just one example of a paper showing done by a group from Taiwan using very experienced users of our CHEPS device. They did a very nice work, and they showed that contact heat evoked potentials are correlated with skin nerve degeneration. They did biopsies and also checked the reaction of the patient to evoked pain. And this is just a paper, just a picture from this specific paper. So you can see that a subject on the left, A and B, is a healthy male, and you can see that the biopsy is normal, and also the evoked potential it looks normal with normal amplitude, and can be detected easily in the EEG. The subject in the middle, C and D, is a patient with diabetic neuropathy. That you can see in biopsy has abnormal biopsy and also absent evoked potential. So showing that decrease in the fibers in the skin result here in absent evoked potential and serve as biomarker of neuropathy, of diabetic neuropathy in this case. And the third patient is very interesting. So you can see in the biopsy that the biopsy is abnormal, but this patient actually had evoked pain as a result of mechanical painful stimulation. So and you can see that the evoked potential exists, and there is some amplitude that can be measured, etc. So the authors think that it can be related to either to the sensitization of peripheral afferents or to the neuroplasticity of central system, because there is some maybe chronification of pain. So it not only gives you the information about the functionality of small fibers, but also gives you some hint about the mechanisms of neuropathic pain in this case. So it's very interesting results. And those of you who are interested in this field, I recommend to look at this paper. Another potential application of CHEPS, of contact heat evoked potentials, is what is called dermatomal CHEPS. The group I already reminded today, a wonderful group in Switzerland, led by Professor Armin Kurt. They developed this technique that is called dermatomal CHEPS. So instead of just testing the hand or the leg, they they know that there is some spinal cord injury, some lesion in the spine, in, let's say, C segments. So they test the C6, C7, C8, or C4, C6, C8, and they by the reduction in the amplitude of the evoked potentials, they can detect the level of the lesion. And it can give additional information in addition to MRI scanning, which give the anatomical information about the lesion of the spinal cord injury. Excuse me. It can give also the functional information, what got damaged, how the small fibers passing there got damaged, and how it influenced the functionality. So this is they published a lot of wonderful papers. This is just one of them, and in which they demonstrate that the diagnosis of cervical spondylotic myelopathy, that specific type of myelopathy, can be improved when you use contact heat evoked potential in addition to MRI scanning. Because in addition just to just showing you the functional information can also show the recovery after treatment, for example. So if you do a surgery or do some another treatment for spinal cord injury, you can really show the course of improvement, not only anatomically, but also functionally. Excuse me. So another example is the use of CHEPS, and we know about some preliminary use even in phase 1 clinical trials, the use of CHEPS to assess the analgesic effect of drug. So if you apply some analgesic drug, you reduce the pain sensation and you reduce the amplitude of the evoked potential. And for example, this paper shows you that these drugs that were used here influence the CHEPS amplitude, and not only the drug itself, but the higher dose resulted in lower amplitude. So again, really very nice paper and very nice potential application. And there are more. I just reviewed the main and the applications we know about, but there are more. There are many uses of CHEPS technique, and it can be done with our new CHEPS for TSA2 device accessory. Sorry. Now, if we talk about cold evoked potentials, another type of evoked potentials, it was not really possible with our previous pathway CHEPS device, because as I said, we could go only to 30 degrees. Some groups were allowed to go to 20 degrees, but it was really, in very slow rates, in lots of limitations, because Cooling was a bit challenging, and now you can go with 40 degrees per second to low temperature. You can go to min peak temperature of 5 degrees, and you can really record very nice cold evoked potential. What is nice about the cold evoked potentials, if you compare them to heat evoked potentials, they are not painful. They don't need to be painful, because we know that cold is mediated solely by A delta fibers. So if you do this fast cold stimulation and you don't see a good evoked potential recorded by EEG, it can give you information about A delta fiber functionality. And as I said, some preliminary work was done, but this is a nice paper published recently by Ralph Baron group in Germany by Philip Uhlemann. They used this going to 20 degrees with our previous pathway CHEPS device, and even with going to 20 degrees, they were able to record evoked cold evoked potential, with not very large amplitude, but they were able to record it in healthy volunteers, of course. And then when they applied the block on A delta fibers, they demonstrated that there was absent evoked potential. So they proved in a way that the evoked potential was related to A delta fibers and its functionality. Now, when you can go to 5 degrees in much higher rates, 40 degrees per second, you will be able to receive a much more detectable and much more easily recordable evoked potential as a result of cold stimulation. And if we look at the software for a moment, I want to show you some. First of all, I want to show you how cold pulses look. So again, you can start from any baseline from 30 to 45. Here I started from 32. And you can do nice evoked potentials, 40 degrees per second down and 70 degrees per second up. You can control the time between the stimulations. You can control the destination temperature, going to 10, to 7, to 9, etc. Now, one more thing I would like to show you, very relevant for evoked potentials recording, is the synchronization. So you have here standard events part, and you can here ask for TTL, for example, at the onset. It means that our device will send a TTL trigger at the onset of each trial, meaning at the starting of the fast ramp. When it starts heating or cooling from the baseline, your EEG device will receive TTL from TSA2 device, and it will mark the beginning of each trial, making it easy later after you do some noise cleaning and averaging of the evoked potentials recorded by your EEG device. You can easily calculate the latency of the evoked potentials. So if I will show you how it looks like, you will now see when the stimulation starts, you will see this asterisk here, this X, I don't know how to call it. And this means that the TTL event was sent by the TSA2 device to your EEG system now. So let's go back to the presentation. So one more potential application and potential use of the CHEPS for TSA2 is temporal summation, and to be more specific, phasic temporal summation. Temporal summation and phasic temporal summation is a phenomenon in which the subject receives repeated and equal intensity noxious stimuli, a series of these, and there is a facilitation increase in the pain experience, even though the stimuli are equally intense, the first one and the last one, but the subject will feel the last one more painful than the first one was. And to be able to test this phenomenon is you need high frequency. You need frequency higher than 0.3 hertz. And for this, you need the fast stimulation, the fast rates of the CHEPS has to offer. Uh, and one more, advantage of using the Medoc device and software for that you can easily assess the results. The results of temporal summation is the comparison between the pain rating of the last stimulus versus the first one, which can be done in our software, and I will show you how in a minute. Or if you're using a very nice Medoc COVAS accessory that connects to the same software, you can have your patient or subject rating his or her pain continuously through all the series of the stimulation, and you can see the increase in the pain in a more continuous, less digital way. And I will show you how it looks like. So the CHEPS for TSA2 allows you everything you need to perform a phasic temporal summation test. It has precisely controlled stimulation at high rates that can maintain the required high frequency. And you can use either COVAS or a pain rating in the software to rate the pain and to compare the pain at the end to the pain at the beginning. What is it used for? What is it good for? So first of all, it can show and it can give some look at the disease or pain mechanism. In some types of diseases, there is a increased facilitation, and the other there is a decreased or absent facilitation. For example, in the papers below, you can see that people who are living with HIV and chronic pain have enhanced facilitation, and the people with sensory modulation disorders, on the contrary, for example, have absence of temporal summation. So it really helps you to better understand the mechanism of the pain and how the disease develops. It can also predict or assess the treatment outcome, and also can predict pain chronification. For example, there are works in temporal summation and its relation with post-operative pain, post-surgical pain. People with specific pain processing profile are in higher risk to develop post-operative pain. There is also a very interesting approach suggested by Professor Yarnitsky here in Israel about the individualized pain modulation profile, which takes into account the facilitation part, assessed by temporal summation, and the inhibition part assessed by CPM test. And these two in combination show the patient or the subject a pain modulation profile, and these can predict reaction to treatment, tendency to develop chronic pain, etc., etc. So many interesting applications in your research for this protocol. So if we go to how to, you can configure your phasic temporal summation protocol either using pulses or using ramp and hold. You remember we mentioned the differences between them. In pulses, you control the destination, the baseline, and the software just uses the maximum rates and zero duration for each pulse. In ramp and hold, you can control the rate. So if for some reason you don't want it to be 70 degrees, but you want it to be 50 degrees, you can control it. And you can also control the duration. So if you want the stimulation to be maybe a little more painful, like we mentioned in when I was answering one of the questions, you can increase the duration a little bit, not use zero duration, but 0.3 seconds or 0.2 seconds, and then the stimulation will feel more robust, more painful, and you might need to use lower temperature to achieve the same level of pain. You can use COVAS in both pulses or ramp and hold programs, and you can use pain rating feature only in ramp and hold. In pulses, it is not available. So if we again look at our software, the temporal summation done with pulses will look something like that. You will have a series of rapid stimulation with short ISI, because remember, you need to keep the high frequency. So here I ask for 2 seconds between stimuli to stimuli, and you can use the COVAS. Your subject can use the COVAS. You can see the blue line on the screen. So the COVAS shows the pain sensation of the subject continuously, and the subject can rate it continuously from 0 to 100. Again, here I'm using the simulation of the COVAS, but your subject will, of course, have the device itself and will be able to use it. I just want to show you how it looks like in the software. So this is how your temporal summation protocol, depending on how many repetitions you want. I just ask here for 10 to shorten it a little bit, but I know that people use more than 10. This is how it will look like if you will use pulses. And this is how it will look like if you use ramp and hold. So in this ramp and hold program, I just want to show it to you. I asked for a destination of 49. I asked for maximum rate because there is no reason for me to ask for slower rate. And I asked for the duration time of 0.3. So you will see that the peak will not be this sharp. It will have a little short duration, and it will be sensible enough to make it more painful. And I asked for pain rating. I asked to enable pain rating. You will see how it looks on the screen in a second. So we will run this ramp and hold. Oh, sorry, I will remove the COVAS back. So you can see that you can rate the pain using this window of pain rating. You can see that the pulses are less sharp. So you can just ask to rate the second one and then the sixth one. To ask, of course, the patient how he or she feels and record the rating in the software. And for example, the last one. And you have the digital pain rating recorded by the software. It will be saved in the results, can be exported to report, etc., etc. So this is also a very nice option that you can use. All right. So we are almost at the end. Before we finish, I just want to review some additional possible uses of CHEPS for TSA. I already mentioned the CHEPS fMRI thermo that will be released soon. And its main advantage that it will allow you to do very fast, high temporal resolution stimulation in the scanner, reaching the destination fine, shortening the time of testing in the scanner, full synchronization with your fMRI device using TTL, for example. So many exciting options. I mentioned that the always mentioned that the thermal works in fast rates, but it is equally stable and precise when working at slow rates. So you can do limits or levels. Of course, the surface is smaller than the 30 by 30 thermal. So if you want to rely on the normative data, you will of course need to add also the 30 by 30 thermal. But if you just want to, before you do the temporal summation, you want to check the pain threshold of the patient to have the temporal summation be a little bit above this, you can do this with the same CHEPS thermod. You can do the assessment of pain threshold using the limits program, and then build your phasic temporal summation protocol based on that. And you can use the ramp and hold protocol not only for temporal summation, you can use it for another dynamic QST modalities. For example, you can use this stimulation as a test stimulus in CPM testing. If you, for example, combine it with a pressure cuff, you can have pressure cuff as a conditioned stimulus and use the CHEPS thermod as a test stimulus. So it can be, it can help you in different parts of your research protocol. And another capability that we reviewed in our TSA2 webinar, and I would like to just briefly talk about now, it's the external control option. This option is built in the TSA2 software, and it enables some external programs, MATLAB, ePrime, LabVIEW, anything you are using, to just communicate with our software, Medoc main station software, send some commands to it, control the stimulation to some extent, start it, stop it, define the intensity of the next sequence, the next trial, etc., etc. And it can also pull from the Medoc main station software some output about temperature at each time stamp, etc. And this is the feature that allows you to really implement the thermal stimulation in more complex research protocol, in more complex research environment, using different types of stimulation, using task, and according to the subject, how subject does in the task, give painful or non-painful stimulation, for example. Many exciting capabilities and options. And we will have a specific webinar dedicated to external control, so stay tuned. Those of you who this option is interested in this option, we will have a more detailed review of this and how it can be used and configured. So thank you for your time. We will just have another question session at this point. I want to see if we have additional questions. Just one moment. So we do. So there the questions are is this accessory compatible with the old model? So unfortunately not. This is the accessory for TSA2 device. Previous pathway CHEPS has its own CHEPS accessory with its capabilities. Can reference values be used in reporting? So I believe you mean the reference values, the normal values of CHEPS. The thing is that the normal values are for EEG, for the evoked potential recorded by EEG. So we can't implement it in the software because we only give the stimulation. The EEG records the evoked potential, and you do some post-processing of averaging it, cleaning some noises, and seeing this amplitude and latency. There are normal reference values published, so you can use it, but it's not part of the software. And if you ask about limits or QST reference values, the standard normative data is not applicable to this thermal because it's smaller than 30 by 30, which is usually used for QST. But if you collect some normal values, you can implement it in the software and use it and compare to them. So if you need more information about it, just feel free to contact us. So one more question: can the CHEPS be used clinically? Well, we do know about some places in the world, in the UK, in Switzerland, in Taiwan, in which CHEPS is used clinically, mainly for two main reasons. From what we know, one is the assessment of small fiber functionality to neuropathic patients, to see how A delta and C fibers are functioning by the amplitude of and the latency of the evoked potential. And the other one is the technique I mentioned, the dermatomal CHEPS. We know that they are using it also clinically to assess the level of the lesion, to look at the treatment effect, etc., etc. I just want to see that I don't miss anything. No, I think that this is it. So I would just like to thank you very much again for staying with us, for joining our webinar. I hope it was informative and interesting for you. As Odelia mentioned, we will have a very, very short survey after. You will be redirected to that actually after we finish this webinar. So we will be very grateful if you could answer a few questions to make us to help us improve and make next webinars even better. Thank you very much, and see you in the next one.